GMAT all day.
On the GMAT, not only am I always looking out for patterns in general, I'm also looking for specific reoccurring patterns. So for example, difference of squares. I'm always on the hunt for difference of squares. And when I get an exponent question that I don't know how to do, one of the first things I do is look to see if there is a difference of squares, because difference of squares, the key to solving them is just recognizing when you have them. And another common recurring pattern is consecutive sets. And consecutive sets have special properties, and those properties are there to make your life easier. And so consecutive sets can mean two things. It can be a literally consecutive set, so 20, 21, 22, 23, 24, 25. That would be one example. Or it can be a consecutive interval set. So that would be 20, 23, 26, 29, 32. Each of those will be considered a consecutive set and have the properties of consecutive sets. So what are these properties? The first property is when you have a consecutive set, the mean will always be equal to the median. And so if I give you a big set of numbers and they ask you to find the median, well, that would be too hard to do because the set's too big. If you can find the mean, then you should also have the median, and vice versa of that is also true. What is our second property of consecutive sets? So with consecutive sets, the mean is not only equal to the median, the mean is also equal to the first term plus the last term all over 2. So if I give you a really big set, oftentimes you wouldn't want to write out every single term and then have to find the middle term. So it usually is easier to find the mean because you don't have to sum up all of those terms and then divide by 100 or something. You just have to do the first term plus the last term divided by 2. And then the last property of consecutive sets, this isn't a property of consecutive sets. This is a property of all sets of numbers, but it comes up commonly with consecutive sets. And so that is the sum for any set of numbers should be equal to the mean times the number of terms in the set. And so the reason this comes up most commonly with consecutive sets is because if you think about it, if you were to be given truly just a random set of numbers, it usually would be pretty hard to find the mean. So if you're given something like 12 numbers and they're random, it would be very hard to sum up all those numbers and then divide by 12, and then you don't even necessarily know if that would give you a decimal or an integer. And so with consecutive sets, though, they can ask you to find the mean of really big sets of numbers because you can use this equation here. So let's take a look at a consecutive set question. What is the sum of all the multiples of 7 between 100 and 300? So they're asking us here for all the multiples of 7 between 100 and 300. So one thing to note is these numbers here, this isn't our first and our last term because they're only asking us for the multiples of 7. And 100 definitely is not a multiple of 7, and 300 is not a multiple of 7 either. So we have to find our first multiple of 7 and our last multiple of 7 that are within this range. So what is the first multiple of 7? So what's 14 times 7? 98. So 15 times 7 should be 105. So our actual range should be 105 through. And what's our last term? 40 times 7 is 280. 43 times 7 is 1. So our 42 times 7 be 294, or 290, 294. So this is our actual range. So good, if you wanted to talk about multiples of 7, we're talking about 105, 112, 119. You can write out every single term, or you can do what we did in the last problem and just write out the first few and last two, because I know I'm not going to have to actually sum up all of these terms or write them all out and find the middle term. I don't have to, because I recognize that we have a consecutive set here. So now to find the sum, first I got to find the mean. So let's use our formula here to do that. Just be 294 plus 105. And remember, it's the first term plus the last term. That's not the last term minus the first term. That's the range. And for some people, for some reason, people always want to use that here. It's not the range. It's first plus last. So this is over 2. So this is what? 399 over 2. So this is going to give us a decimal. Fortunately, it will be a decimal ending in 0.5. So 400 divided by 2 is 200. So this should be 199.5. I'm probably just going to use fraction because I prefer to use fractions when doing arithmetic. So now we need to find the number of terms. So if we had a literally consecutive set, the way to find the number of terms is just the last term minus the first term plus 1. So if it's all the numbers 1 through 10, there are 10 numbers in that set. So it should be 10 minus 1 plus 1. And the reason you got to do the plus 1 is because both the 1 and the 10 are included in our set. Now, when we talk about multiples of 7, we'd actually have to do last minus first plus 1 and then all of that over 7. We'd have to divide our terms by 7. But I find that a little bit confusing because I always forget, do I divide by 7 before adding the 1 or after adding the 1? So usually what I do is I say, I look at my range here and I say, okay, 105 is and we found it before, is the 15th multiple of 7. And then 294 is the 42nd multiple of 7. And so when I do this, now I can just do last minus first plus 1 with these boundaries here. So sum should be equal to our mean of 399 over 2 times how many terms do we have? 42 minus 15 is 27 plus 1 should be 28. And I'm glad I kept my fraction like this because I see now this 28 should cancel out my 2 and I just have 399 times 14 should be my answer. I do a little bit of multiplication here. One good thing is, I see here 9 times 4 is 36. So once I get this, I know my actual answer. This is the benefit of multiple choice tests. I know my actual answer has to end in a 6, so I can eliminate 3 of the options just beginning here. So 9 times 4 is 36. Put 3 up here. 36 again plus 3, 39. And 1 times 9 is 9. And again, 3. So sum here, 6, 15, 15, 15. So 5, 5, 8, 6, C. So these are your properties of consecutive sets. These absolutely should be memorized. Copy paste these, print them out. They are there to make your life easier, not harder. Oftentimes consecutive sets, you see them as higher point total questions. So that's only the case because if you know the rules for consecutive sets, it's an easy question. Whereas if you don't know your rules for consecutive sets, it's near impossible. And so just know the rules. And that's one way to get some difficult points. Let's do one more consecutive set question.